Hello everyone, welcome back to Building Enterprise Agentic AI Systems. If you remember, we start this series with the full reference architecture. There are 9 layers, each one has a specific job to do. In layer 1, we built an AI gateway where every request gets authenticated, authorized, checked against the policy, and logged before it touches a model. In layer 2, we built the agent planner. It broke our churn analysis query into 3 subtasks and called a different tool for each one. SQL for structured data, CRM for live account data, and a third tool called the knowledge layer. Today is layer 3. We go inside the knowledge layer call and show exactly what happens. The agent planner called it as a tool, but what actually ran inside the call? How does the agent retrieve context from the enterprise documents? How does it know which chunks are relevant? And how does it make every client traceable to a source? This is what this episode is all about. Let's get into it. Okay, so I'm going to let's run a full demo. Like I'm in a NexusIQ, so I'm going to start in layer 1, the AI gateway, and then the same query we have been using across the entire series. Let me add the query here. Yeah, so the query is all about analyzing Q2 customer churn risk across enterprise accounts, identifying the top 5 risk regions and suggesting next action, and sales team including relevant product insights. So the role will be manager and the customer, and I'm executing it. So I don't want to go deep dive. So just one thing we need to notice here is tool registry. If you see here, yeah, so SQL layer, knowledge layer, and CRM all are approved. The model router selects the reasoning models, and there are 3 tools approved, right? SQL, knowledge layer, and CRM for this particular query. So, yeah, so it is approved now. So I'm going to run the planner. So the same query is coming from there. This is a sequence, like we are running this. Tick complete. Yeah, so one thing we need to notice here, the query has been decomposed into subtasks, 3 subtasks. The historical sales and churn metrics is required, which will be using SQL, and product trends from the knowledge base, that is for knowledge layer, and high risk customer accounts, that is from the CRM API. So let's move on to knowledge layer. So I am on layer 3, the knowledge layer, the same query preloaded from the gateway. So let me hit retrieve knowledge and walk you through what happens. Okay, perfect, good try. So if you see here, we'll go step by step. Step 1 is to receive query. The query arrives from the agent planner as a tool call, knowledge tool call, not from the user directly. The planner decided it needed document context and called this layer as a tool, and then generate embedding. The query text gets converted into a vector using mini LLM, the LLM model. This is very important because this is not a keyword search. The embedding captures the semantic meaning of the query. The product adoption signals will match against feature utilizations threshold in our documents, even though those exact words are not in the query. 3 is semantic search. The embedding is compared against every chunk in ChromaDB using cosine similarity. So ChromaDB is the database, the vector database which we are using across this NexusIQ platform. So this is running against relevant document we loaded, right? So it's not a simulated results or something. This is from the actual document we loaded, and re-ranking by relevance score. So let's look at this. Look at these scores. The Q2 channels report scoring 77%. The channels report scoring 71%, and the product. This is like it's all about product adoption, and then the regional sales performance from scored almost 70%. These are similarity scores. The higher the scores, the more relevant the chunk is to our query. The knowledge layer is not just finding documents, it is ranking them by how well they answer the specific question. So step 5 is quality filter. Chunks below zero point 0.5 similarities are removed. This matters more than people think because uncertain retrieval is worse than no retrieval because it gives the model something plausible but weak to reason from. We know we only use or we only pass high confidence context forward. So add citations, like every written chunks gets tagged with its source document and page number. So if you see here, the Q2 channels report from page 1 and the same from page 2 and the original sales from page 2. Yeah, the citation travel with the context all the way to the model. When the model generates its answer, every factual climb is traceable back to a specific page of a specific document. So we'll return the grounded context to agent planner for synthesis. Uh, so if you see here, there are three chunks retained the token, and there are certain milliseconds, like 207 milliseconds we got these answers, and there are 408 tokens are being used. So look at the right panel here. So grounded chunks. The grounded chunks are there with their scores and page where it gets from the page citations. And the note at the bottom is very important. If you see here, this chunks ground the model's response is in verified enterprise documents. The model cannot fabricate facts, contradict this context. This is what grounding means in practice. So what just let me tell you what just happened. The agent planner called the knowledge layer as a tool. The knowledge layer converted the query to a vector, searched ChromaDB using cosine similarity, re-ranked the results, filtered out low confidence chunks, added page level citations, and returned grounded context in some 207 milliseconds. The model never generated a single word yet. It is still waiting. It is waiting for all three tool calls is complete SQL, knowledge, CRM before the planner synthesizes and hands everything to the model to the final response. This is architecture, right? The model is the last thing that runs, not the first. Now think about why this matters for enterprise especially. When your legal team or audit team ask where an AI answer come from, you can point to a specific page of a specific document. This is not something nice to have. This is important and must have feature. And it's important when you're architecting for enterprise level of AI adoptions or something. So what is layer 4? The layer 4 is like agent memory. We have now run the same query, same chunk query 3 times across 3 layers. In an enterprise system, the agent should remember what it retrieved, what it found, and what it recommended the first time. That is the difference between a stateless tool and an agent that learns. See you in layer 4. Thanks for joining.